right, welcome to this podcast. In this episode, we're going to be looking at how to calculate the median. Specifically, when calculating the median, there's a set number of steps that you need to follow, and it matters whether the set has an even number of elements or an odd number of elements, as we'll see in this example. I'm also going to show you how to think about this in your calculator and how to go about using the calculator to sort of help you through this process. Let's go ahead and start with a couple of things that we can notice right off the bat about this particular example, and that is counting the number of data points. There are n equal to 20 data points. That's going to be helpful. We acknowledge here up front that this is an even number of data points, and so that'll definitely be a part of our calculation going forward. What you should start off by doing, and this is usually always step one when it comes to the median, is you should sort the data in ascending order. Ascending means starting with the smaller values and then getting bigger. So sort in ascending order, and I'm going to use my calculator to actually have that happen. In this case, if I sort in ascending order, the first thing you notice is that I enter the data set just as it is. Go ahead and hit enter or solve there and gets it into the calculator, and then I'm creating another data set, which I'm going to call data set Y, and that's the sorted version of X. You can see how everything's nicely sorted for us. The other command that you should be aware of is the size command, and that simply tells you how many data points there are. And so I'm going to use this information now that I have a sorted version here. I'm going to use this information to my benefit to just be able to quickly read off the data points. And so let me go ahead and write these in for us. So we've got the data points in order now: 1, 5, 5, 6, 8, 9. There's 2 10s, 12, 13, 14, 2 15s, 16, 17, 18, we're almost done, 19, 21, 22, and finally the last data point is 100. So there is our entire data set, and one of the things that you should be looking to after you've sorted in ascending order, next step coming up, is to find the middle, because that's what median means. Now the question is, how do you locate the middle? Well, that's an interesting sort of problem that we have here. The middle refers to where the median is located, and the median position is always the n plus first divided by 2 position. Now let me explain what I mean by this. N is the number of data points. So in this case, n is 20. So there are 20 data points, and I am going to enter them like so, and that gives me 21 over 2, which is 10.5. Now let me explain what the 10.5 number means. It means the middle is somewhere between the 10th and the 11th entry. So this is 10th to the 11th position. In other words, it's exactly halfway in between. So let's count over. We have our set here. Let's count over until we get to 10. And I'll just mark them off as we go. But we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's the 10th position. There's the 11th position. What that means is the median is halfway between the two. So what do we mean by halfway in between the two? Well, we actually mean the average. So step 3 is to actually calculate the average. Well, in this case, you would have that the median for this problem is the average of position 10 and position 11, which is just the point halfway in between is 13.5. Now, if we were in our calculator, this could actually be made pretty easy for us. Let me show you how you would handle this in the calculator. The first thing I want you to look at is I went ahead and calculated the median position. I just called it median position as being 10.5. So that means the median is located between the 10th and the 11th positions, and the key thing here is in the sorted list. So if you recall, the sorted list above, I used Y as my sorted list. So down here, what I'm going to tell the calculator to do is to extract from the list Y, which is the sorted list, starting with position 10, the next two things. In other words, I'm telling it to pull out or extract the 10th and the 11th position in the list, which, as we see written down, is 13 and 14. The calculator gives us those values as well. And then to find the median, all we do is average those two values. So that's actually kind of nice. That's actually the hard case for the median. The easy case for the median is, what if instead of having the problem as is, I had one less value, let's say. Okay, so suppose for this particular problem, I didn't have the value 16. So let me just go ahead and get rid of 16. So 16 is no longer in the problem. Then what that'll do is it's going to take me down from n equal to 20 now to n equal 19, which is an odd number of values for this problem. And with there being 19 values, how would this change the middle step? Well, locating the middle no longer looks like this. The middle would be 19 plus 1 divided by 2, or the 10th position. Notice that we don't have a range of positions anymore. We're looking for the actual 10th thing. And so calculating the average here, where there's no average to actually calculate, if you look, 13 is the median. It is the 10th position. So it's actually much easier in the case where there's an odd number of data points. The last thing that I want to mention here is when looking at this particular data set, one of the data points just sort of pops out. We would call this an outlier. We've used this language in class, and you'll see it coming up later in the semester. But an outlier is a data point that doesn't really fit the rest of the set. Now, here's the advantage that the median has over the other types of statistics that we calculate to determine the center of the data set. If we were to perform the average of these data points, that 100 would really pull the average way up. However, for the median, notice that in both cases, the median stayed relatively in the center. It stayed near 13, 14, 15, which is, you know, if you were looking at this data set, you would say is the center of the data set. So the median is not subject to extreme values. And that's sort of an important thing to remember. The median is not influenced. So we'll say it this way. The median is not influenced by extreme values. That makes the median a wonderful aid for determining data sets where you have a large number of data points and there may be a couple of really extreme values. Say, for example, salaries. So if you were trying to average salaries, if you had someone at the place where you work that had a really, really large salary compared to everybody else, then that would throw the numbers really off. And so a lot of times what they do is they calculate median salaries as opposed to the average or the mean salaries. All right, thank you for watching this podcast.